India today marks a major milestone in its nuclear energy trajectory. When we are talking about the prototype fast breeder reactor at Kalpakkam has finally reached the stage of criticality, and this needs to be celebrated because this marks the beginning of era where there will be production of electricity by indigenous prototype built in India. Hello everyone, welcome to Vajiram and Ravi's Flash News. My name is Shubhangi Singh. Today we will understand that what has been achieved at Kalpakkam. What exactly is criticality, why it is important, and where does this land us in terms of stages of the nuclear plant that we are following. So let us begin with understanding that what exactly has happened. So when we talk about today's achievement, the first thing that you need to understand is that we were building an indigenous prototype fast breeder reactor. We will be moving to understand what exactly is fast breeder reactor as well. But as of now, let us just establish that this is what that has been worked with, and this particular reactor has reached criticality. So if I have to simplify it for you, it basically means that this reactor has become alive, it is functional now, which was very important. Now this is a 500 megawatt nuclear reactor, and given the fact that this is an indigenous built-in technology, this marks a huge milestone for us. Because this is not just about a scientific success, this is a step towards energy independence, especially in the era where we are seeing what are the costs of being energy dependent. So basically, after so many years of research, India's advanced nuclear reactor has started working at the basic level, which is criticality. That means it has become now a self-sustaining nuclear reaction creator, and that nuclear reaction has begun. And this is the first step before electricity generation begins out of it. As I explained, the reactor has become alive. Now it will be working steadily from here on. Now to understand this better, let us break down all the concepts around it, starting with understanding that what exactly is nuclear fission, which is very important for a nuclear reactor to work, and what is this stage that we are talking about, that is criticality. So when we are talking about nuclear fission, as we understand by the word, we get to see breaking happen here. When we are talking about fusion, we see assimilation, we see coming together. Fission, we see breaking, which is the main body in our solar system where we see fission happening. Can you tell me in the comment section? Now, what exactly is fission? This is where a heavy atom, for example, plutonium, or we have uranium, this will split into smaller parts, right? Now, this split will lead to release of energy. With energy, when we are talking about breaking in smaller parts, this will not just come with energy, the smaller parts will also lead to release of neutrons. Now these neutrons will further attack or go towards heavy atoms and break them down. Now this leads to a chain reaction, which we can see in the given diagram. So for example, we see that a heavy atom is being broken down, there is release of energy, and then you can see more neutrons which are coming out of this. They are going to break the other heavier atoms into smaller particles, they will release neutrons, and so on. So this sets in a chain reaction. Now when we are talking about criticality stage, this is the place where this chain reaction becomes self-sustaining. That means it can continue on its own. Criticality is a very important stage when we are talking about nuclear reactor, because it means each reaction will only lead to one more reaction. That means the process will be stable and also continuous. So in this case, you get to see it is not too fast, that means dangerous, and it is not too slow, that this process will stop. So this reaction becomes not only balanced because of criticality, but it also becomes self-sustaining. Please remember here, when we are talking about criticality, it means that the reaction has become self-sustained. Criticality does not equal to electricity generation. electricity generation will also come into the picture once later after the testing is done. Okay. Now we are clear with what is nuclear fission, what is criticality. Now let us move to understand that why we have the PFBR, that is the Prototype Fast Breeder Reactor, that is special. And when we are talking about Kalpakkam, this reactor is not an ordinary reactor that has been built. So let us try to understand the dimensions around it. So when we are talking about PFBR, that is Prototype Fast Breeder Reactor, the reason this is special is it makes more fuel than it uses. If we are talking about usage of fuel for setting the reaction, yes, it will use fuel, but at the same time it will also create fuel. That means it also produces new fuel while generating energy. We will be understanding this first and then we will come back to this. Now when we are talking about creation of new energy, first we have to understand that when we are looking inside the reactor, it has two parts. The first is core, where energy is produced. The second is the outer layer, basically the blanket around the core. Now this is the place which has uranium-238 present. Now what happens is, when neutrons are being produced in the core, they start hitting uranium-238, and this is where uranium gets converted into plutonium, which is the new fuel we were just talking about. Now going back to the other special features of this reactor is the fact that this uses a very special fuel, that is uranium and plutonium comes from the used nuclear fuel itself. So the used nuclear fuel, as I said, it generates, it comes from there. Another special feature here is that it uses liquid sodium, not water. So in this context, it helps heat to move faster and it also helps to keep the reaction efficient and moving. When we are talking about all these features, another thing that makes PFBR very special and a milestone here is very much relevant to the India's nuclear plan that was not decided 10 years, 20 years back. It was decided in 1950s by Homi Bhabha. So let us straight up move to understand first that what exactly is this trajectory and the nuclear program that we are looking into, and then how this PFBR is going to help us in another manner. So when we are talking about the three-stage nuclear program, the stage 1 is about uranium based reactors, where we are using natural uranium directly, we are producing electricity and we are also producing plutonium as a byproduct. But the stage 2 is the presence of fast breeder reactor, which we have reached now, where we are using plutonium as fuel, not uranium, and we are further producing more plutonium and we are also preparing thorium for use. At this stage, PFBR is present, and after this we have to elevate to stage 3, where we will also have thorium based reactors, because thorium is present in abundance in India, but when we are talking about uranium, the resources are very limited. Can you tell me in the comment section that which states are known to have reserves of thorium in our country? Now problem with thorium as of now is the fact that thorium cannot produce energy directly. We need to pass through this stage 2, and this thorium needs to be converted into uranium-233, which is a usable fuel. For this, what do we need? PFBR. When we will have this, when this will be tested and it will be functional in long term, we will be able to convert thorium into uranium-233, and this will ensure our energy independence for a very long time, because we have seen a very long time where we have been energy dependent. Now what are your thoughts on this? Let me know in the comment section, but before moving to the end, let us also talk about what is coming up next for India's nuclear program. The first thing, we will be testing at low power generation, PFBR, we will be having proper safety check, and then the connection will be brought to the electricity grid. This is a huge significant achievement. Why? Because this is a step towards energy independence. It is a step towards where India will be able to use its own resources which have been present with their own technology. This is a clean and reliable energy, directly puts us in place for net zero emission target that we have taken place, and definitely it sits effortlessly with India's long-term plan where we wanted to move from uranium to plutonium and towards thorium because of the reserves we have. Now I'll be leaving you here with the prelims practice question. Let me know the answer in the comment section. That was all from my side. Thank you so much.